All right, let's run example number 2. So again, we need to start by determining what u is going to be equal to. In this case, we don't have an expression that's 1 degree greater than some other expression. So what we're going to do is just use the larger expression. All right, so what I mean by that is x minus 1 is just a little bit larger than just x. So we're going to let u be equal to x minus 1. I mean, if you think about that, if you were to take the derivative now of each side, this is going to be nice because all you get is what? Just 1x, or excuse me, just 1 dx, right? Okay, but wait a second. We still need to come up with this piece of the puzzle. See, right now we have what? Right now we have this piece taken care of, and we have this 1 dx, or just the same as dx. We have the dx taken care of. We have to account for every single piece. The only piece that we're not going to be worried about is this radical, because we can rewrite that as the quantity of whatever this is, right, to the 1/2 power. But we're still trying to figure out what we can let x be equal to, and we have to make this x be something in terms of u. Well, here's how we're going to do that. Look at this original statement, u equals x minus 1. Here's the trick. Are we ready? Drum roll. All we have to do is what? Isolate x in this original equation by adding 1 to both sides. So I'm now going to add 1 to both sides of this equation, giving me u plus 1 equaling x. So now this x component right here is accounted for, and it's going to be equal to u plus 1. All right, so let's see what we do next. At this point, we would go through our motions like we did in the previous example. And so we don't have any coefficients to write down here in this particular one, so we're just going to put our integral symbol. And then we're going to change our limits of integration based upon what u is equal to. Everything now is going to be in terms of u. There's no going back to x. All right, everything's going to be in terms of u. You don't have to ever go back to x. Okay, so x right here, your lower limit was originally 1. Plug in a 1 into this x. 1 minus 1 is 0. 0 is your new lower limit of integration, okay? When this thing is in terms of u. All right, 5 was our initial upper limit. Now plug it in, plug it in. 5 minus 1 is 4. Put your 4 right there. Okay, let's rewrite this thing. Let's piece it together. So remember what x is equal to. X is the same as u plus 1. So this whole thing, x, is going to become the quantity of u plus 1. All right, the next part, x minus 1. All right, x minus 1 is just u. Now, this x minus 1, again, is under a radical. And we should all know that this in radical form can be rewritten as what? 1/2 in exponential form. And then you put your du on the end to make sure we account for the dx, and we're all set. Okay, first move is not to evaluate the definite integral. Our first move is going to be to rewrite our definite integral. And notice through the magic of video editing, I changed this du, at least I try to, from being completely black to blue, so you can see how it's being pieced together. Okay? All right, fantastic. So first step is to distribute this u to the 1/2 through the quantity of u plus 1. And so we would get this, u to the 3/2 plus u to the 1/2, closed quantity with respect to u. All right, now we're able to evaluate this definite integral. So I'm going to put that work down here so I have more room. All right, so what's the value of this integral? Well, that's going to be u to the add 1 to 3/2. 3/2 plus 1 is 5/2. Then you divide by that new exponent. Plus what? U to the 1/2 initially. So that's u to the 1/2 plus 1 is 3/2. And then you divide by that new exponent. And you're going to run this based on these limits of integration. All right. Now, at this point, let's go ahead and do what? Let's rewrite this. Because you don't want to have these fractional denominators. So when you divide by a fraction, it's the same as multiplying by the reciprocal of that fraction. And so we'd end up with this new expression. Okay. Now we're finally ready to evaluate this thing. So we found the value of the result of the integral in terms of u. Now we're able to evaluate it based upon these limits of integration. So here's what we would get. 2/5 times what? 4 to the 5/2 plus 2/3. 4 to the 3/2. And this is really going to be what? This is going to give us our value at the upper limit, which is 4. What we're really doing now is we're going to subtract off whatever we would have come up with for the value of our lower limit here. But because our lower limit is 0, and we don't have anything, that would give us a result other than 0 when we plug in a 0 into every u, we don't have to worry about it. Okay, hopefully that makes sense to you. All right, so let's figure this out. 4 to the 5/2. That's going to be, get your calculators out. That's going to give us a 32. And then 4 to the 3/2. It's going to give us an 8. And then, let's see, plugging this into our calculator, we would get what? We'd get 2/5 times 32 plus 2/3 times 8 would give us this. Then you hit what? Math, enter, enter. So our final result is 272 all over 15.